All right, let's find the equilibrium here. I'm going to show you how to find the equilibrium, the one force that adds to these to put the situation in equilibrium. I'm going to show you that with an equilibrium expression. Okay, so the first thing you do is you draw the components of it. I'm going to draw the components of A here. A goes up and to the left, like that. Notice that this side touches it. So this is what 37 is the hypotenuse, cos 29, and then this side here is 37 sine 29. And the reason it's sine is that it's what opposite the opposite the angle, right? And 37 is the hypotenuse, right? And then this little guy here has a component there. That guy is what, 25. It touches the angle, so it must be cos, right? Cos 11. And then this guy here, that little bitty guy there, that little vertical component there, is 25 sine of 11. Okay. Notice that that's positive and it's in the y direction. It's going up as well, I'm saying, right? This guy is negative and in the x direction. This guy goes to the left, so it's also negative and in the x direction. And then this guy here is positive and in the y direction, so it's positive. Okay, so now what we got to do is we got to set up our equilibrium equations, right? We're just going to add up all the forces. Now there's a third force called the equilibrant. Okay, that's this guy here. And I'm going to just find the x component of the equilibrant here. Okay, it's going to be such that, what do we got? We got this guy in the, we've got negative 25 cos 11. And then we got this guy here, the negative 37 sine 29. And then we've got some component, E, I'll call it the equilibrant in the x direction, adds up to 0. It's some number such that all the forces in the x direction add to 0. And then in the y direction, let's look at all the ones that go up and down. We've got this guy here, right? Positive 25 sine 11. And it's sine because of what it's opposite that angle, right? And it's positive because it's up. And then we've got positive 37 cos 29. Is that right? Yeah, those are both positive, plus something in the y direction, which will almost certainly be negative, right? Because these two are positive. 0, right? And now we just do math. We want to solve for EX. So I'm going to take everything in the parentheses and just negate it. So the opposite of left parenthesis, negative 25 times cos 11 minus 37 sine 29, right parenthesis. And I get 42.4786 positive. Right, and that's my x component, right? And then let's find the y component. Basically, I'm going to take everything in the parentheses and just negate it. So the opposite of left parenthesis, 25 sine 11 plus 37 cos 29. That's negative 37.131. And that's in the y direction, right? So now we just got to draw a picture of this guy. Let's go over and down. Down not quite as much, right? And then the equilibrium is this, right? So the magnitude of it is the square root of 42.4786 squared, right? Okay, so and then plus 37.1311 squared. Don't put the minus in there if you have a TI calculator, or you'll be in for a nasty surprise. It'll, yeah, anyway, it doesn't make it positive when you square it. Okay, so let's see, alpha x squared. I stored these in registers in my calculator. It's alpha y squared. So I'm squaring this, squaring that. 56.4 is my, and that's newtons is my hypotenuse, right? And then let's find this angle right here below the, let's see if we can get that, right? That's going to be inverse tan of the opposite over the adjacent, right? So this is 37.1311, 42.4786, right? So the opposite is, and 42. I'm just using SOHCAHTOA is what I'm doing here. Okay, so inverse tan of alpha y divided by alpha x. This is my y, this is my x. 41.157 degrees, or 41.2 degrees. All right, I hope that helps.